Hello, thank you all for being here to this MergeBase webinar. My name is Jim Manico. I'm one of the advisors, investors at MergeBase, and I'm here with someone a little more important than me. This is Julius Musso. He's the co-founder and CTO of MergeBase. He's a senior architect and developer. He's been an IT professional for most of his adult life. He has a strong academic background and roots in the open source community. He's a contributor to a number of open source projects related to security and other topics. And he's a Billie Eilish fan. Just went saw her live. I am too. She's awesome. Julius, how are you doing today, sir?
Jim, that is a wonderful introduction. Thank you so much. Yeah, so here we're going to talk about Dependabot. Hopefully, everyone's heard of Dependabot. It's a SCA tool. That is, it's a tool that alerts you, helps you identify stale and vulnerable dependencies in your software systems. And we're going to go in deep on it and kick the tires on it a little here and see what's going on there.
Let's do some kicking. And look, Julius, the reason that this webinar topic got my interest when we were planning is because Dependabot is an application security industry darling. No one tends to talk smack about Dependabot. And it's often cited in courses, in webinars, in talks like this as best practice, right? So Dependabot crawls your site, sees out-of-date security problems in third-party libraries, and issues you a PR so you can go and update that library. And doesn't that just sound great? That sounds like, oh, my problems are solved. And so again, when I look at application security educators and speakers and consultants, Dependabot is a big recommendation as a solution to the problem. And there's a deeper story here, isn't there, Julius?
Mm-hmm. Yeah. Just building there on what Jim is saying, right? So Dependabot started in 2017 by a pair of very talented developers, Gray Baker and Harry Marr. And initially it was really focused on NPM. So it came out of the NPM Yarn world, the JavaScript world. And it's actually, you kind of see that tools, they tend to be very strong in the languages they started working on. And then as they grow out their support to support more languages, well, you know, their initial focus was really JavaScript, right? So that's where they're really strong. And then as they grew to, you know, do support for C#, for Java, for Python, right? Well, you know, Gray Baker and Harry Marr, they were fundamentally, I think they were JavaScript. I mean, I haven't met them, I haven't spoken to them, so I can't really speak for them, but you know, I just get that suspicion looking at their work that their core talent was JavaScript, right? And so then the C# and the Java implementation here ends up being a little bit of an afterthought.
And Julius, this is not the first code-centric application security scanning tool that's had that arc, right? If you look at all the code tools like DAS, dynamic analysis, that's mostly live running against the website. So it does JavaScript analysis typically, at least some of it. But all the others, static analysis, software composition analysis, and IAST even, they usually support like a handful of languages well. And as their customers demanded other language support, it's not always as mature. And so some of the biggest enterprise tools that claim wide language support, what they're really trying to say is we cover these core languages as well. And we check a few boxes in the other to get you to buy our product, but we're not putting a lot of time investing in it, maturing it, nor are we going to, you know, augment it unless you really complain. This is a common story in application security tooling is what I'm trying to say.
What would you say this? A very quick summary of like, what is the SCA problem, software composition analysis problem, often called the open source problem, right? Is that you develop your in-house code and maybe you're going to break it out into components, in-house internal components, but then those components themselves, they're going to depend on open source libraries, right? And then I actually have an academic paper coming out in a couple months where we actually looked at this empirically, and we saw situations where like 99.9% of the code, like that's if you take the system and you you just count all the lines of code. And so we saw systems that had, say, 5,000 lines of code up in the top of the pyramid, and then they had like 2 million lines of code if you counted all the lines of code in all the libraries, right, coming from these open source libraries. And if you think about that, right, like, yeah, your little 5,000 or your 10,000, or, I mean, it depends on the significance of the system, right? This was a small internal system that we studied at Ford Motor Company. And so it was a small internal system, 5,000 lines of code internal, and then 2 million lines of code from libraries, Spring mostly, right? And this huge attack surface you're bringing in, right? Those 2 million lines of code, attackers can come in and maybe they'll find a bug in a few of those lines of code that they can then exploit to their advantage.
Can I ask a hard question?
Mm-hmm.
Other vendors claim that as you use open source and you have open source vulnerabilities, that they question exploitability, they question if that vulnerable code matters. And how good is our industry at understanding if a vulnerable component is really going to be a problem in your software or not?
Yeah, my gut says exploitability, like the true like gravity of the situation when a vulnerability is announced. I think out of the gates, we often don't really have a good sense. It's like, well, that code, that's a bad habit, that's a code smell. We've seen situations where that type of code has been exploited. Is it reachable? Can it be, leveraged or lifted into the runtime such that an attacker can get in and exploit it? Of course, you see situations like struts or log4j or heartbleed, where, empirically we see the exploit, the 0-day in the wild. In that case, I think the industry is really good at like sounding all the alarms and getting everyone on top of that. You got to patch this log4j. It's popping sites, right? Like it's taking down Minecraft servers. But in a situation where we see, clearly a bad piece of code, and we see that there's serious security issues with this code, but is it actually exploitable? It's a lot of work to build an exploit. And it's also a lot of work often in your own environment to prove to yourself I'm exploitable. And it's often a lot less work just to upgrade and just take the newer version. Like, why spend days proving that you're not exploitable or you are exploitable when you can spend, maybe hours just taking the new version?
The point I'm trying to make is some of the tooling in like the third party software composition analysis space. They're claiming they'll let you know if a certain function is going to be a problem for your software or not. That's really hard to actually prove. And I
Oh,
see a lot of false positives where they say, yeah, this is really a problem. You're using this function, but for some other compensating control that they didn't catch, it's actually not exploitable. Or the opposite. They say,
yeah, yeah,
oh,
yeah.
this is not exploitable. Don't worry about it. Well, then there's all these like dynamic invocation of functions
Yeah,
and other kinds of things that tools don't discover real well. Oh, it actually is exploitable. So
yeah.
I like the idea of using a tool that tells you whether or not this library is really a problem or not. And I'm skeptical of vendors that claim to do that because I know realistically how fragile of a process that really is.
Yeah, I totally agree with you. That like I've seen blog articles from security vendors where they literally say, like, use our tool to see that this code is not reachable, not invoked. And it's just
Yeah.
like, it's not true, right? Like, I have seen situations where they say, oh, you're not using Commons file upload in your system, and so therefore you're safe. You can just keep going as things are. And it's like, and then I've gone and taken that exact same system and used an exploit to then lift Commons file upload into the runtime and exploit it. So it's like the vendor saying that that wasn't exploitable is completely false.
Good stuff. Brian Myers jumps in and says the term I heard from SCA providers is reachability, right? They're trying to provide reachability info, how a component can be reached through your own code. And my comment to that, Brian, is when it comes to things like dynamic function invocation, which is something libraries use a lot, suddenly reachability is way more difficult to accurately do through a tool.
Yeah,
And second, that's why they're using the term reachability. Reachability does not at all mean exploitability. And again, just because you see reachability doesn't mean you're seeing all of it in an accurate way by this class of tools. Is that fair,
yeah. I
Julia?
think for me, like, exploitable, loadable, runnable, is equivalent to on disk. If it's on disk, it's loadable, it's runnable. Even if your code doesn't normally go into that area, and even if your code can't even be configured to go in that area, once an attacker's in, they're going to find a way to load it and run it. So just assume everything on disk is reachable. So that's why I kind of don't like that reachable term, because I think everything's reachable.
Most of my customers who like really care about application security, they don't worry about reachability and they don't worry about exploitability. They keep their libraries up to date. Because the other big problem, Brian, is suppose you see that code is not reachable in a library, so you don't update it and you keep not updating it. And now 3 months go by, and now 6 months go by, then a year goes by. Guess what, Brian? Then you do have to update it. And because you haven't touched that library in so long, your actual time to update is going to grow over time. And most of the banks, most of the companies that I see that are really putting effort into managing third-party components, they're aiming to keep it either fully up to date or like 1 or 2 point releases behind up to date, regardless of reachability. Log4j showed us that reachability is way more complicated than we think it is. That's my take on that subject, for what it's worth.
Yeah, totally agreed. Just a little take there on like what tools do you use for what parts of your system?
Oh, I like this.
Yeah, you're going to use SAST, static application security testing, to test your own code for vulnerabilities. But SCA is really what you're going to use to manage all those software dependencies. Of course, the SAST vendors, they love it if you take all those libraries and shoot them over to their tool, like, Coverity or Vercode, right? Like they're fine, like, oh, your system was 10,000 lines of code, that's only what, $500 a month. Oh, you want to shoot the 3 million lines of code from all those libraries at us? Sure, we'll do that. Yeah, it's going to cost you more. But no, SCA is the appropriate tool for staying on top of those libraries down there. So we've got some chat. Oh, that's you, Jim.
Hey, do you want to answer this question from Brian? Brian follows up. This is Brian Myers, who's following up with, the problem that reachability is trying to address is prioritization. If you have a long list of SCA findings, Julius, is there any better way to prioritize the work than the vendor severity rating? I have my opinions on this, which you can see in the chat.
Yeah, I mean, if I were, I would just be completely improvising if I were to give an answer here. I can tell you my current improvisation on this, and tell me, Jim, what you think. Is RCEs, I would more prioritize by that. Like RCE is a really awful category, right? And so if you've got potential RCEs, potential SQL injections, right? Like things like that can really like take down your data or cause your data to walk out the door. I'd maybe prioritize by that, regardless of reachability. And then once those are done, like DOS, denial of service, I think is more tied to reachability. So if a vendor says it's reachable and it's a DOS, then it's like, that makes sense to me. What do you think, Jim?
I like it. So what you're saying is you would aim to prioritize based on the criticality of the problem, and you wouldn't give reachability a big weight when you're making decisions of what to update first, because you and I both know how difficult reachability is to truly discover technically, and we're dubious of competitor tooling reports on that. That's my translation. I think that's a very reasonable perspective. I like it a lot.
But how would you prioritize?
I don't believe in prioritization. I believe in keeping your damn libraries up to date.
Oh yeah,
and I'm serious. And I'm serious. If you're prioritizing, what that means is you're doing a legacy challenge, right?
Yeah.
But what I'm aiming for is to either keep my libraries fully up to date, or even better, just 1 point release behind fully up to date, to avoid the supply chain malware type problems we're seeing more often.
Yeah.
And look, usually it's the legacy groups that are like, hey, I haven't really updated my code, done security, or updated my libraries in years, and now I need priority. Which library should I update first? And I'm like, this is not this is a kind of, I feel like at some level it's almost a foolish question that there's no good answer to. Well, the answer is you need to go through a pretty massive security set of security sprints to fix the BS problems. You should update your whole inventory of third-party libraries, all of them, and go back and fix that. So you're at a baseline, and then moving forward, let's try to keep them up to date by using an SCA tool and a DevOps automation lifecycle. That's what I recommend. And for a lot of my customers, that's what they're doing, because I realize this is a big problem. For the other customers that want to prioritize, I really don't have a good answer. And it's not a strategy I recommend. Not at all. And I recommend that you keep your damn libraries.
Keep them up to date.
Julius.
What about the prioritization by CVSS, like by the base score?
Again, I'm a little more hardcore. I'm not into it. Here's why I want to keep my libraries a little more up to date. Why I personally struggle with prioritization. Now, let me take a step back. Now, Brian, you have to do prioritization sometimes. You got to start somewhere. And I like Julius's advice. Aim for the critical vulnerability types, regardless of reachability, and start there. That's sage advice. It's subtle. I haven't heard that before. And I think it's really wise. But what I'm aiming to do is reduce my use of third-party libraries, use SCA tools like MergeBase on a check-in basis. Every day, I'm using it as a check-in blocker before I'm allowed to check in code. Like if I'm checking in code and MergeBase says, hey, you got this library out of date, and I got to go fix it before I can do my merge. That's I prefer that kind of process for software I'm actively working on. Waiting months and updating on a quarterly basis or doing it before release, I just don't believe in those processes as effective ones. And if you're a big company with lots of legacy software, there's no good answer for you. You can use whatever third-party library tool you want, and they're going to light you up with things you got to fix, and it's going to be a massive amount of work. And also, you're going to have to go back to the code, probably fix authentication, probably fix access control, and fix a host of technical problems like XSS, SQLi, request forgery, tuning, updating your framework, reconfiguring your framework. Real legacy software is something that's going to make us all bleed, and there's no clean answer to deal with it. Hard work, sweat, and tears.
Okay, well, I'm going to move on here to really like that's a great recap and overview on SCA. We have one Q&A here. Severity rating, base CVSS score from Hung No is a theoretical worst case scenario. They don't take compensating controls and environmental factors. You've got to do your analysis. My answer to that, and I seem to be a bit of an iconoclast here in the application security industry, actually, honestly, about CVSS, is like I see so many people saying like CVSS, prioritization by CVSS by the base score, don't do it, it's bad, it's wrong, it's a shortcut, you know, you're going to get popped by a 5.5 sometimes, and sometimes you're going to get popped by a 7.0, and you know, sometimes you're going to get popped by 9.8. It's all random, right? But I feel like, well, look, the whole reason we have the CVSS base score and this, you know, ridiculous one-dimensional projection of severity, right? Like, yeah, severity is so context dependent. So it's sort of insane to project it onto a one-dimensional linear scale between 1 and 10. But we are so overloaded and so busy that you know, you need that projection. You need a one-dimensional projection. You need less information and less context, because context is expensive. So I kind of feel like, you know, you got to handle your 10s. Your 10s are a disaster. 9.9s, 9.8s, definitely get those done. And then once all your 9.8s are done, now you can maybe start looking at being more smart and more context around that. But, you know, we're so busy, we're so overloaded that I think that we have no choice but to make the best with crappy data. And CVSS base score is, you know, it is crappy data, but better data is too expensive to use. That's my iconoclastic take.
I'm with you. And Hung, again, my philosophy is CVS is a great guide. It's like a high level, like I'm not in your code kind of guide, but I don't really care about the CVSS score so much. I keep my libraries up to date, not just for security, but also for like functionality, performance, all the other good things in computer science. And I also keep my libraries up to date for updatability, because the longer I wait to update my libraries, when I am going to be tasked to update it, it's going to be real painful. So Hung, how do you like your pain? Do you like it a little bit at a time throughout the year? Or do you like a massive dose of it on a quarterly basis? And I recommend you take it a little bit at a time and get into a process where you're not concerned about CVSS, that you're using a mature tool to identify these problems early, and you get your developers to update and handle it as you go. That usually requires extensive QA and unit testing and similar. And it's an effective strategy when it comes to security if you're able to move in that direction and process libraries like that in your SDLC.
Okay, now I will dive into a Dependabot focused take on this problem.
Thanks.
Okay, so here fundamentally Dependabot's problem, if you look at Dependabot carefully, is it can only find all the vulnerabilities, including the dependencies of the dependencies, if there's a lock file. So if you have a package lock.json or a gem lock or a yarn.lock, if you have those in your Git and you've committed them to Git and pushed them up to your Git server, to GitHub, then Dependabot is able to use those lock files to examine the complete dependency tree. And then it can find the vulnerable libraries deep in that dependency tree, right? When is there a lock file? Yeah, lock files are pretty much out of the box standard usage with JavaScript, PHP, with PHP Composer. Go has used, I think, has used lock files pretty much for the last 5 years, and then Ruby as well. Well, what if there's not a lock file? So here, this is the core of our webinar today. You know, when is Dependabot dependent not, right? Well, it's dependent not when there's no lock file, but Dependabot's not really going to tell you about that. Dependabot's not going to say, alert, alert, you know, no lock file, so I'm severely degraded. Instead, Dependabot's going to look, in this case, what we're saying is that this particular software system has 6 direct dependencies, and then those 6 direct dependencies are bringing in like 50 or 60 additional sub-dependencies. Well, Dependabot's
that's usually called transitive dependencies.
Yeah, gotcha. Or indirect. I hear the term indirect dependencies or transitive dependencies. Exactly. I prefer transitive myself with my fancy academic.
I like indirect. I like indirect.
You like indirect
with my more workman kind of mentality.
Yeah, I love it. Yeah.
Academics.
And so what if there's no lock file? I mean, I put an asterisk up to .NET because .NET supports lock files, but I think most people don't turn it on because you have to actually do some config to turn on lock files with .NET. It's not out of the box. Whereas with JavaScript, they're pretty much turned on right out of the box. So Dependabot's only going to look at those 6 libraries, and then lo and behold, there's the bad ones. Dependabot's going to miss those because those are in the transitives or in the indirects, right? What is a lock file? It's funny, lock files themselves have nothing to do with application security, and they have nothing to do with the open source problem. Lock files solve a different problem. They solve, build repeatability. And so you see things like yarn lock, package lock.json, composer lock, and we use these lock files so that everyone on your team is able to build the same software system with all the same libraries. So you auto-generate this lock file. For example, every time you type npm update, it's going to go and update the lock file and tweak the versions a little bit. And then now that you've got a nice updated package lock.json, you're going to add that to Git, commit it, push it, and be like, hey, I updated the package lock. I ran npm update, everyone. So now we're on newer libraries. But again, because you're using the lock file, your whole team is all on the same versions.
Look, this is a big deal. I've heard a lot of talks on Dependabot. I've seen a lot of research on it. I've messed with it quite a bit myself. No one's ever talked about this before. Why is this? This is such a big gap, and there's not a lot of discourse on it. Any thoughts on why that is?
Yeah, I mean, maybe now it's time. Now someone has come along and noticed the problem. I don't know. I really don't know why this doesn't get more coverage, because it is kind of, I think, dangerous for people turning on Dependabot thinking it's helping them, and they might not be getting as much help as they think. And just a quick, I'm just going to show you a lock file, right? So here is a package.json. That's a JavaScript file. So I'm running a little JavaScript project, and very simple one. And I'm saying, okay, I'm going to depend on version 3.0.0, but I put that little caret in front of it. I don't know if you can see that little caret in front of the 3.0.0 of jQuery there. Well, that means I want version 3.0.0 or anything that is essentially compatible with that, forward compatible, mate with minor releases, exactly, endpoint releases. So this means I'm willing to take a 3.9.x, I'm willing to take a 3.1.x, and generally you want your tool to pick the newest that is compatible. And so if I run npm update, it's going to make a package lock.json that sits right beside on the file system. They sit next to each other in the same directory. In this case, you can see npm has gone and said, well, if you're going to take caret 3.0.0, the newest, largest version that's compatible with caret is 3.6.0. Caret will never grab a 4.0 or a 5.0 or a 10.0 or whatever. It's only ever going to grab a 3. something. And it's going to grab the newest 3. something it can. So that becomes the package lock. But the nice thing about the package lock is it's going to also take the full tree and write the full dependency tree to disk in this file so that everyone on the team has the exact same dependency tree in their software system. So now diving into Dependabot and where it's not so great, well, it's not so great with languages that don't have lock files. And I'm probably the most famous language with the least support for lock files at all is Java. And the reason Java doesn't have lock files is lock files are born from chaos. I don't know if anyone
Born from chaos. What's that? That seems pretty extreme. That seems like something I would say.
Yeah, right. Well, if you say in your dependency file, like if you go back to this, right, like give me anything 3.0.0 to 3.9.0 and anything in between, just give me something that satisfies that, right? There's a lot of different versions of jQuery that you might end up with, right? And so the problem in the npm world is that they had these range, version range idea, whereas Java didn't really have a version range idea. In Java, you would say, I want jQuery 3.1.2, and that's the version of jQuery I want. And that's all I'm going to get, right? You wouldn't have these wildcards and these range specifiers. So what happened in Java is if I built my Java project today, even though I didn't have a lock file, it's pretty much going to grab the same versions.
That's some sloppy craziness. That seems really what's the word? Chaotic. Okay, I got you. Born from chaos.
Whereas if you were doing npm, in 2013, before the lock file feature landed, it was insane. Like every developer on your team was going to have a different version of the software, essentially, with different libraries. And so when they're going to have different bugs, and two developers over there are like, oh, I did an npm install and now it doesn't build, and someone is like, yeah, I did it yesterday, I ain't touching this, and someone else from a month ago, right? Like everyone, even people within an hour of each other, would type npm install and they would get different versions and different variations. It was untenable, actually. Like all the front-end developers were just getting nothing done. Once you reached like 500 or more dependencies in your system, like those developers, npm has DOS'd them. They are not going to get work done, and so they had to solve this, and so they used lock files. .NET. So .NET supports lock files, but not enabled by default. So no one's going to turn it on. And then I think another reason people don't turn it on is because you turn it on and then .NET's like, okay, let's add these 300 files to Git, right? And it's always like, whoa, I have to add 300 files to Git. So developers might have a bit of hesitation in that moment because you'll have one log file per CS proj versus one log file per .sln file. And then, hey, lock files are available to Java lately, but only if you're on the latest version of Gradle. And again, you have to turn it on. It's not enabled by default. Now, the thing about lock files is they make SCA, the software composition problem here, the help fix your vulnerability libraries. They make this problem easy, right? SCA, essentially, SCA tools are solving two problems for you. Problem one is, we want to identify with great accuracy all the libraries in your software. And then once we've identified all those libraries in your software, we want to tell you, the safe versions to upgrade those libraries to avoid known vulnerabilities. Jim?
Yes, sir.
Oh, were you saying something?
No, I'm nodding and I'm
Oh.
nodding, listening, and smiling. So I'm with you so far. I spent a lot of years using SCA software composition analysis tools. I used to call them like third-party security scanners, and SCA is the more formal academic term that the industry has picked up. This is any class of tool that's looking at your development project, can scan the local development project, not live running code, but your IDE within your IDE, to look for the libraries you're using and to map them against a variety of databases and vulnerability databases and similar, to see if they have known security problems in them. And this is an emerging, really serious emerging area, as we see so many industries that don't do this well. And we saw Log4j recently, which messed up the entire software world because of this specific problem. So like this kind of tooling and this kind of assessment need is growing in importance and need as these incidents show up over the last couple of years.
Exactly. And then one thing I like to say here is that SCA is actually a much easier if you have log files, right?
Gotcha.
Both of these problems are actually quite hard, surprisingly hard. Like if you take the random software developer off the street and you ask them like how hard to identify all the libraries in your system, they'll be like, it's easy, the dependency files say. But once you dive into it, it actually is a horribly hard problem with all sorts of edge cases, unless there's a log file. Log files make step one easy. Now step two is still hard, but you pretty much half your problem is solved thanks to the log file. Okay, so back to the problem at hand here. There's no lock file, so we're on SCA hard mode here, and Dependabot is not going to find the vulnerabilities. And then I just here for the webinar here, let's see for ourselves, right? Like it's what Julia's claiming here. Is it true? So I'm going to share a different screen.
And Log4j is interesting because it's trivially exploitable to lead to remote code execution. This is pretty bad. Easy exploit, huge amount of impact and criticality. I got to find me some Log4j if I want to do security.
Yeah. One thing that's handy that I like about Dependabot is that if you do a push, so here, this is Log4j as a direct dependency. And you can see, and this I've specified it directly, Log4j core. That's the bad version, right? So when it's a direct dependency, my claim is Dependabot is fine in this situation. And sure enough, I'm just going to do the build. Can you see this okay, Jim?
Yeah, I see this great.
Okay.
I love the font color choices here. Reminds me of my mainframe days in college. Here we go.
Yeah, sure enough, it's made a little web application, and Log4j core is there on disk. So that means, we're vulnerable. We're going to get popped. This is a very bad vulnerability. And let's see, what does Dependabot think? So I just do a little empty commit just to do a git push, because Dependabot, one thing that's very nice about Dependabot is it gives you a little message when you do the git push, right? And so I went and I looked at the report at this URL, and sure enough, it's finding that Log4j vulnerability. It's critical. It's saying, yeah, you've got a bad version of Log4j. You need to fix that. So that's the direct situation, right? And
I love it. It's working. It's doing its job. We like it so far.
So here, I'm going to go to the Log4j indirect or transitive. Same situation. I'll do the Maven clean. Look at the POM file. So here, what I'm depending on is this library instead. It's Twilio 8.6.1. And then if I do the build, it's going to bring down Twilio, but it's also going to bring down all the additional libraries that Twilio itself depends on. And just in case anyone who uses Twilio or anyone from Twilio is on this webinar, this is Twilio very quickly released a new version right after the Log4j version. So don't worry, Twilio is not vulnerable anymore. They were on top of this. They upgraded right away. But because Maven really prefers that everyone leave old Maven releases up there. The old version of Twilio is still up there, so I can depend on it just for this example here. And sure enough, so Twilio came down, but then Twilio brought all the libraries it depends on. It depends on all of these libraries in addition. And sure enough, this bad version of Log4J is there, right? So bad version of Log4J is on disk. This is bad.
And this is what Twilio just grabbed. Grabbed as a transitive dependency. Gotcha.
And then
good. Everything's clean. Everything's looking clean.
And then I do the git push, and whoops, sorry, I forgot the allow empty. And then I do the push, and GitHub took the push and then didn't say anything and just accepted it. So if you recall when I had the direct example, and GitHub warned me that there's vulnerabilities, but when I had it as a transitive example, GitHub did not warn me. And I can go, let's go look at GitHub as well. So guess I will share my whole desktop. And let's just go to GitHub. Can you guys see that?
Yep. We're looking at your browser screen here. All right, here we go.
So when I go to my Log4j direct example, it's warning me, we found bad vulnerabilities, Dependabot alerts, right? And it's got all Log4j, Log4j, Log4j. That's great. That's the Log4j direct. These are public repositories, by the way. If anyone wants to go to GitHub/MergeBase and play with these yourselves, they're available for anyone to play with. So here's the transitive example. There's no warning file up here. Then I go to security. Let's see the Dependabot alerts. Go to the Dependabot alerts. You're all good. You got nothing. You're clean. You're all good to go, right? So that's not good.
This hurts me. And at what scale is this happening across all of GitHub? It's probably pretty significant. This is bad. Julius, we can't just leave with the problem on the table and a depressed webinar. I need a solution. I need to know what to do now so I can actually deal with this problem.
Okay, how about we use a real SCA scanner? Right?
All right, let's see what you got. Let's see what you got.
Okay, so and MergeBase obviously is in that class. So I'll just go to the Log4j direct. Do the scan here in the Log4j direct example. And so, just like Dependabot, Log4j, MergeBase is able to find the vulnerability in the Log4j direct example, but what about in the transitive example?
All right, here we go. What you got, MergeBase?
So recall that Dependabot said you're all good, no vulnerabilities.
Yeah, you're good. It's transitive. Yeah, exactly, Eli. That's what we're doing right now. Boom, found it. Why does MergeBase find transitive dependencies at this level when other industry-leading tools do not? Is this something you can talk about, or?
Yeah, absolutely. Here, I'm going to go back to the presentation. I'll just back up there. Yeah, so I mean, the reason, right, that MergeBase and other full SCA tools, right, as I call it, real SCA tools, are able to find the transitives, right, is because we're not relying on lock files exclusively. Like, certainly we'll look at the lock file and consider it. But we're also, we're going to ask Maven, tell us, Maven, like, what do you think the full dependency tree is? And I mean, I think part of the limitation here, right, is that Dependabot is trying to provide SCA, basic SCA coverage for, millions of GitHub repositories and forks, etc. Right. And so they really want to try and limit the amount of compute they're doing for their scans. And so just
Gotcha.
looking at a lock file or looking at the direct dependencies in a POM file, right, that's the least amount of compute possible that can provide some basic support. Whereas actually, coming in and saying, okay, Maven, you tell me what the full dependency tree is. Well, that's a lot of compute. That's a lot of network.
I got you.
Even in a small example like this, probably Maven's going to do at least 50 downloads of different POM XML files to calculate the full tree.
Oh, gotcha. And at GitHub scale, that becomes really expensive compute time really fast.
Exactly. So does Dependabot know about this limitation? Yeah, they do. And you can see on Dependabot's blog, they like all the SCA tools, MergeBase included, we all, to us, Log4J is a disaster for industry.
Okay.
But, it's like a huge...
Sorry.
Go ahead.
That is some sneaky stuff.
Oh, the language there, yeah.
No, it's like, I'm just saying, it's been years that the entire AppSec community and all my GitHub friends and who are very well-meaning, solid professionals have been telling me I can depend on Dependabot for a lot of years. And
really?
And this is not just a small gap. This is a major gap. And this article from Dependabot, it's a few months old. So I'm just frustrated that we let 5 years of Dependabot love go by before this is really being talked about, how radically limiting this is at finding the deeper problems. So I'm surprised and I'm a little disappointed. And I'd love to get Dependabot team's feedback on this and what they're going to do about it. Like, as an enterprise tool, I'd want them to let me flip into a more high-powered mode to find these dependencies. And it shouldn't be something that the world has not really been aware of, because I think everyone that I know of until this moment has been very quiet or just didn't know about this problem. And it's disappointing. That's a lot of years of poor assessment in the Java world, especially.
Yeah, and in their blog post, by the way, they didn't underline and italicize those two words. That I added. That was my emphasis.
All right, that's your emphasis. Yeah, I'm just a little bit shocked. I'm gonna go I'll go light up the Java Champion community and mention this, and they'll spread it out to other folks in the Java world, because I know a lot of people in the Java world are using GitHub and depend on Dependabot, which is not as dependable as I thought it was, to do really important security. So I'll go spread the word on this. It's crazy. I'm just feeling just emotionally challenged from this. That's all.
I just have a side note, or as I call it, some sad news here. For this presentation, for this webinar, I also wanted to show the same problem with .NET. I suspected Dependabot would have the exact same problem with .NET, where it can only do the directs, can't do the indirects. And I was even more disappointed with .NET. And so with .NET, Dependabot, couldn't find the transitives, couldn't find the directs either. And I put together a bunch of repositories. They're all public. They're in the MergeBase repository area. And I was preceding them with pretty significant vulnerabilities. Could not get Dependabot to bite or bark or to do anything. Dependabot just was like, yeah, these are all good. You're all fine. So that was frustrating.
Take a look at what Hung just posted. So here we have an October 14th Dependabot core issue asking about transit dependencies, and
I do see that. So from 2020, an issue was logged. Hey, Maven transitives. If anyone has had any success getting Dependabot to scan .NET, though, please let me know. I would love to see a scan of a .NET project where Dependabot is raising vulnerabilities, because I've been having trouble. I could not get it to do that. And I tried a whole bunch of variations. I tried the old packages.config style. I tried the newer .cs proj where it's embedded. Yeah, couldn't get it to find anything.
So they've mentioned it in marketing posts. There's multiple issues logged against this problem that has very low to no activity. No one's really talked about this at conferences or similar. And this is just this mammoth gaping hole in one of the most premium tools in dependency management. I'm not being dramatic. I'm still shocked trying to process how big of a problem this is. And I'm like thinking of like, as soon as we're done, what I'm going to do to spread the word on this. That's what's going through my mind right now. And it makes me happy that MergeBase has got the maturity to handle these kind of problems. That's what I expect out of you, damn it, Julius.
Of course, of course. Well, and then this here, if you go to Dependabot's documentation, they have this. And it's really, they really bring it out, right? Like they really emphasize this. This is a screenshot. I didn't copy paste this. This is not my emphasis. This is not my decorating. This is the color that they put on their own documentation in this, with this pink background saying GitHub does not claim to catch all vulnerabilities, right? And I just, for a security tool to just come out and say that right in their documentation, we are not catching all vulnerabilities. We try our best. These are not substitutes for human review for potential vulnerabilities or other issues. We recommend consulting with a security service or conducting thorough vulnerability reviews of your own code when necessarily. Personally, as a vendor of a security tool, I don't really like this. This is not something I would do. I would never say to my customers, you know what? We try our best, but our best is honestly pretty shitty, right? Like, I mean, they're not saying that, but that's kind of the feeling I get here.
Linda Fay has a good comment. She's like, but Julius, no tool claims to catch all vulnerabilities. I think what you're trying to say is a little more nuanced than that. Give it to us one more. Linda's making a good point. I don't know of any tool that says, oh, we catch it all. And if they do, they're lying, right? The point you're trying to make is more nuanced. What is it?
Yeah, well, as a company with your own vision, I just don't think you should be putting this caveat up on your homepage in your documentation. I feel like by putting this on their website and on their documentation, they're sort of letting themselves off the hook, right? Of course, yeah, Linda's absolutely correct. No tool ever is going to catch everything.
But I see your point. A lot of our industry does find these problems. MergeBase does have the ability to find transit dependencies. That capability in the SCA tool is there. But GitHub consciously made the choice not to do this, probably for performance. And rather than actually give me the capability to do that and do that extra work, they instead say, oh, no tool finds all problems, and try to wash their hands of the matter. And a major area of their tool that all these other vendors, especially MergeBase, addresses, that's the problem, Linda. That's the nuanced problem here. They're trying to let themselves off the hook for something that's extraordinarily weak capability when you compare them against other SCA tools. That's the problem. And I think it is a significant problem.
Yeah. So
I got you along. Linda, is that helpful commentary? Do you think that's a bit fair? Do you have a follow-up that we can address? I think that's a fair comment, though, and I'm trying to address it respectfully. We're talking to Linda, one of our attendees right now live.
Yeah, I'm just waiting to see. Yeah, Linda's saying it's fair.
Yeah.
Okay, we have a question from, well, let's do Long. Made a comment that it's like a disclaimer to get out of trouble if there's litigation against them since it's free. Yeah, I kind of feel like that in a way, or at least maybe not legal trouble. I'm sure they have stuff in their end user license agreement that gets them out of that anyway, but maybe more like to get them out of trouble, like in terms of bad attention or bad media or bad press, to be like, oh, we've always claimed that, we're just sort of a better than nothing tool. We never claimed to be like a truly excellent, amazing tool. I've got a comment from Leonard. I can see the benefits of MergeBase for Java, but any benefits over Dependabot for Yarnlock? Okay, so we also benefit from lock files, of course. And they make our SCA easier for us as well. So the benefit is definitely diminished once lock files are available. However, I would say MergeBase still does have advantages in those cases. And for example, we tend to have a better picture of all the known vulnerabilities with all those libraries. So that's the other issue, right? Is that, there might be 28 known vulnerabilities in a given set, and Dependabot might only raise 15 of them, and MergeBase is more likely to find all of them. And then also we have a better idea of what versions you can upgrade to. And we've got a great link from Kirill Kirov on how Maven's dependency mechanism works.
You see the questions coming in? One of the questions is, how would you compare MergeBase against MergeBase scanning JavaScript against Dependabot with lock files scanning JavaScript? How is that head to head? Another similar question is, any benefit of MergeBase over Dependency Check? That's the open source OWASP project that handles these.
Oh, yeah, of course.
These are not easy questions either. I like the tough questions. What do you think?
Okay, well, OWASP Dependency Check is a fascinating take on this problem. And they do one thing that's very cool, which is they are explicitly, they're dedicated, I'd say, I just need to be more articulate here. Always the answer is a bit complicated and nuanced, but dependency check primarily is a post-build checker. It doesn't look at the dependency files. Instead, it looks at the actual libraries that have been downloaded to disk, right? And so since OWASP dependency check is looking at the libraries after they've all been downloaded and assembled into, a deployable package, they're also not going to have this problem, right? Because they're literally looking at the libraries on disk. So they're never going to have a false positive in that way. They're never going to be like, oh, we missed a library that isn't on disk, or we made up a library that isn't on disk, right? They're literally just looking at the libraries on disk. So that's always, that's a great approach. The problem with dependency check, and they are very clear about this in their documentation, is a lot of false positives, right? Because they're mapping all the library names to these NVD CPE entries, and that mapping, they run that mapping fairly aggressively because they're quite worried about missing vulnerabilities. And so because they're worried about missing vulnerabilities, they kind of turn the dial more towards, let's not miss anything at a cost of false positives, right? And so MergeBase doesn't have that problem as bad. We have much fewer false positives compared to dependency check. And so makes it a bit easier to use, right? Developers aren't as frustrated or as sort of annoyed by our results because they're not like, another batch of false positives. I don't even believe it. So I think I'm talking too fast and too much, but dependency check kind of can cause a bit of fatigue for developers working with it and patching the findings from it out of it.
So here's the grid, right? Comparing MergeBase against Dependabot, going to be more thorough. Comparing MergeBase against Dependabot, where Dependabot is good. Things like JavaScript, we're going to be on par, comparable to them. Comparing MergeBase against dependency check, we're going to have less false positives. Sorry, Jeremy. And comparing MergeBase against the expensive commercial tools, we're on par with them. Radically less expensive, radically. You don't have to sign an NDA to get pricing on what we do here. We'll give you clear, transparent, no bullshit pricing, unlike all of our competitors. There's a compare grid. I think we're nearing the end of our day, Julius. I think it's time to wind it down.
Yeah, let's wind it down. Yeah, thanks everyone. Thanks so much for coming. Great chat too. That really makes it more fun for me and for Tim.
I appreciate I appreciate Linda. I appreciate Leonard. I appreciate the comments from Bruce earlier and from Hung. So your comments made it shine. So thank you for being here and thank you for participating. Julius, any final thoughts?
At the end of a webinar, I'm kind of like, I'm zapped, right? I my mind is blank now.
I appreciate you all being here. I think we're done for the day. We'll see you all next time. Don't forget to write secure code, please. And thank you for considering MergeBase. We'll see you next time, everybody. Thanks for participating. I appreciate it, Leonard. I appreciate Kirill. And I really appreciate the more challenging questions from you, Linda. Those are really fair questions. Hope we addressed them fairly. Thank you, Jürgen. That's it. We're signing off. Until next
Okay, and
time.
yeah, and by the way, everyone, Jim is a fantastic trainer. Just give him a call, send him an email, bring him into your company, your development teams, your software engineers. They'll thank you because that's some of the best experiences I've ever had is being on Jim's training.
That's sweetheart. All right. Thank you again, everybody. I'm signing out. I'll see you next time. I appreciate you being here. Bye again. Take care.